Hello viewers, in this video we will see about the introduction of compiler design. Compiler design in first unit, it is what is the process of compiler and what is the main difference between interpreter and compiler, what are the different phases of compiler and each phase, what is the work of each phase. So these will be discussed in first unit. So now we will see the process of compiler and about the introduction. See, any high level coding, the programming coding, it will be, if you want to convert into executable file, these are the some phases it needs to cross. Okay, the source code will be sent to the preprocessor. Okay, so preprocessor means that high level language, it will, if it is having the including the header files or macro definitions, like it will eliminate those lines and it will pre-process and it will send to the compiler. So that is called pre-processed code. In pre-processed code, those header file lines and macro definitions will be eliminated and it will be included. And those lines are eliminated code and the header files and the definitions of the macros will be included and it will send to the compiler. So the compiler will convert that pre-processed code into assembly code. Assembly code, it is not a complete binary code, it is an intermediate code which will be having the mnemonic codes. Mnemonic code means like addition, add, sub, mul, like clear. So like that, these are all called mnemonic codes. The compiler will convert into assembly code. That pre-processed code will be converted into assembly code. This will be transferred to assembler. Assembler will convert into machine code, that is complete binary code. It is the combination of zeros and ones. And here we will discuss about what is relocatable in the next time. And after that, it will be transferred to linker. The linker will look at the library files. It will link all the library files, relocatable modules, all the functions, and it will create one object file, that is .obj file or .o file. It will create, then it will transfer to loader, and loader will convert that object file into executable form. It will create all the necessary functions. What are the necessary functions it needs to execute a object file? It will create, it will prepare that program, and then it will send to the memory for execution. So basically these are the steps. If any high level programming code, if you want to convert into executable form, these are the steps. Okay, so here we will see one by one in clear way. First, a preprocessor. Preprocessor is a program that will process the input data and produces the output that will be used as an input of another program. Okay, so here it will eliminate this type of hash include iostream.h, hash include macro.h, like those header files will be eliminated, these lines will be eliminated, and those important header files will be included, that files will be included. And sometimes you will use the define function, that is the def pi, if you want to define the pi value as a constant that is equal to 3.14. So those value will be included and these lines will be eliminated. So preprocessor will eliminate all these lines and produces the output. So after the preprocessor, the compiler, it will get the code, the pre-processed code converts into assembly language program. So example, assembly language, it is a mnemonic code that is equal to add, R1, R2, mul. So these type of codes it will use. This is called assembly language. And again, assembler converts the assembly language into machine language, that is relocatable code. Machine language means it is a combination of binary numbers 0 1. It is a relocatable. So here I will explain what is the relocatable and what is absolute file. Okay, that machine code will be two types, relocatable and absolute. Relocatable means where the sufficient memory in memory, if sufficient memory is available from the second location, it will accommodate it here. Suppose absolute means from the specific location only. Suppose from the 10th line only it needs to execute, means it will execute from the 10th line. Okay, so relocatable means where is the sufficient memory available, it will go there and it will execute. Absolute, the specific memory location we need to tell. That is the difference between relocatable. Here it is, it convert the machine language into assembly language into machine language as a relocatable. Okay, so after that the linker will link all the modules library functions into one file. Okay, suppose these are the two files, that is a main program and one function is there. It will convert, it will link all the programs into one file and generates one or more objective files. .obj file it will create that, it will link all the files and it will create one objective file. Okay, so after that loader will perform this, it will places the program into memory and prepares them for the execution. Basically these are the phases, so which I told, from preprocessor to compiler, from compiler to assembler, from assembler to into the linker, linker to loader, from loader to memory. These are the phases if you want to convert any high level language code into execution time. Between these execution time, from process to execution time, these are the steps. So now we will see what is the difference between, you know already what is interpreter. Interpreter also works like a compiler. We will see what is the basic difference between a compiler and interpreter. So difference between compiler and interpreter is, compiler converts a program into machine code as a whole. The whole program will be converted into assembly language program here, but here interpreter converts line by line. Okay, that is the basic difference. Here whole program, here line by line. But compiler creates object file, that is .obj file or .o file it will create, but interpreter does not need to create any object code file. Here program execution is fast because once the compiler compiled successfully, it will be run many times. It need not to be compiled again and again. Okay, it will execute many times. You can execute it. It need not to be compiled many times. But here in interpreter, whenever if you want to execute, it will recompile again. So that's why program execution is slow. And error detection and removal is comparatively a bit difficult here because the whole program will execute here, and here line by line error detection is comparatively a bit easy here. And example languages of a compiler, which programming languages are used: C, C++, Pascal, Program, Fortran. These are the languages which it was used. And interpreter, Perl, MATLAB, Python. These are the examples. And previous years compiler was designed, first compiler language, it was designed in Fortran language. After that in C, many years the C compiler was used. But in nowadays every programming language designed its own compiler and its language only. And Java is the example for the both it will use it is the example for compiler and for the interpreter also. Okay, so next video lecture we will discuss about the phases, and hope you understand. Thank you.